All right, this is going to be the first of 4 videos. I'm breaking this up over 10 questions for each video for the midterm review to make it a little bit more navigable. So numbers 1 through 10, here we go. Question number 1, what is the remainder of 3x cubed minus 5x squared minus 4x plus 1 divided by x plus 3? We're going to switch the sign. So we're going to say -3. And then we're going to plug in -3. So we want to do 5 times -3 cubed minus 5 times -2 squared minus 4 times -3. -3 plus 1. And this is called the remainder theorem. This has us avoid synthetic division. Put it into Desmos or your graphing calculator. And you get -113. Ooh, I see people have started already. All right, number 2. Which is equivalent to 2x cubed minus 5x squared plus 3x plus 7 divided by x minus 2. Use synthetic division. Well, let's use synthetic division. So again, switch the sign. Put the 2 on the outside. And get your coefficients. So 2, -5, 3, and 7. Remember, we're going to bring down the first one, multiply, add down, multiply, add down, multiply, and add down. So there'll be remainder. This is going to be 1. This is going to be -1x. This is going to be 2x squared. So you write 2x squared minus 1x plus 1 plus 9. And the 9 goes over your divisor, which is x minus 2. So let's expand this out so we can see the right one. And it looks like it's going to be this one right there. All right, question 3. Which polynomial has the following real zeros? We have 7 multiplicity of 2, -3 multiplicity of 1. So this is going to be a double root. And remember, double roots, they hit the x-axis like this. Like you'll say, so like at 7, whether it opens up or down, it's gonna either hit 7 right there, kind of hit it and then turn back around, or it could look the other way, so it might be like this. Either way, it's going to hit 7 and turn back around. And then with -3 multiplicity of 1, it's going to just hit -3 and go through it, either that way or it'll go through it this way too. So you could see either one of those. Let's graph them and find out which one works the best. So we're going to do first, let's see, x to the 3rd power minus 11x squared plus 7x minus 49. And let me analyze that graph. That's going to be, actually, let me put all in here and we'll analyze them one at a time. Okay, so double root at 2 at 7 and single root at -3. Let me look at one at a time. So we're just going to hide some of these, and we'll start with the first one, and that's not it. Second one, this has 3 roots. None of them are double roots. Notice that they single cross the x-axis. This one has a single root there. I don't know what the other ones are. They're probably complex. And this one has, this one's nice. This one's got a double root there at 7 because that's the minimum, and -3. So it's going to be the last one. All right, decide if x minus 3 is a factor of 3x cubed plus 10x squared minus x plus 12. There's a couple ways you can do that. One way, method 1, is to graph the function. And look at where it crosses the x-axis. It crosses the x-axis at -3, -1.333, and 1. And so these factors would be x plus 3, x plus 1.333, and x minus 1. Well, x minus 3 isn't one of those. It's got to give you a 0, a positive 3. So we'd want to see it cross the axis at 3, not -3. So it's not going to be a factor. But we can also use the remainder theorem. We can plug it in. And if your remainder is 0, then it's going to be a factor. So if I do 3 times 3 cubed plus 10 times 3 squared minus 3 minus 12, because I want to switch the sign, I want that to be equal to 0. And it's not. So it's not going to be a factor. All right, the next problem. How many roots or zeros does the equation f of x equals 5x to the 4th minus 8x cubed plus 4x squared minus 6x plus 3 have? All right, you don't need to graph anything here. The number of roots and zeros is the same as the highest exponent. That's the degree. Since the degree is going to be 4, the number of roots is also going to be 4. All right, which function has this end behavior? So looking at the end behavior here, remember the end behavior for this graph here, we want to see end behavior that behaves such that, so this is going to be x is negative infinity, that's left, and then f of x, that's y, goes to infinity, that's up. So we want end behavior that goes left and up, and then this is going to be right, and f of x negative infinity is down. So we want ultimately to be pointing up on the left side and down the right side. Now I don't know what's going on in the middle, but at the end, this is where we want to look for. So we want to analyze our graphs. I'm going to put all these in here. And we got it all entered in the graph, so let's expand that a little bit, hide one thing. Remember, we want end behavior that is pointing left and up and right and down. Left and up and right and down. So one at a time. This would be left and down and right and down, so that's not good. This is going to be left and up and right and down, so that's going to be your answer. And you can see the other ones. This would be up and up, and this is going to be left and down, right and up. So the one we want is the one with the 7 power. All right, another end behavior problem. This one's already graphed for us, so it's going up and up here on both the left and the right side. So that means when x is going right, it's going up. When x is going left, it's going up. So the only one that has the left for x is this one, negative infinity. This should be both an up. That should be that one there. All right, we got an absolute value equation. We'll solve this by hand. We'll check it with the graph. So for absolute value equations, you want to divide both sides by the -6. Get rid of that, that coefficient out there. So absolute value -8p minus 7 is equal to 15 divided by 6. -15 divided by 6, we can use a decimal if you want. -15 divided by -6, which is 2.5. Or you can reduce that to 5/2, your choice. Let's keep that at 2.5, make it easy. All right, so next we're going to do -8p minus 7 equals 2.5. And we're going to solve that out. And that's -8p equals 9.5. And divide by -8. And p is going to be equal to -9.5 over, or 9.5 over -8. That's going to be one of your answers. So 9.5 divided by -8. And I'll go ahead and convert that to -19 over 16. That's one answer, but that's not both. The other answer is going to be, well, it's going to be either -9 over 16 or positive 9 over 16. We get that by taking the same equation and set it equal to -2.5. So add 7 to that. And that's going to be 4.5. And then divide by -8. And p is going to be 4.5 divided by -8. And that'll convert to -9 over 16. So it is going to be -9 over 16 again. And this one was -19 over 16, so they're both negative. So it's going to be that one. Now before I click on that, I do like to check with the graphs. So what I'll do is I'll put -6 absolute value, -8x minus 7. You got to use x and y in Desmos. And then I'll say y equals -15. And I'll see where these two cross. So let's take a look at where they cross. They cross at those two values, -1.188, which is, oh, that's not round, that's not rounded. So -1.188 and -0.563. And if I do -19 divided by 16 and -9 divided by 16, you can see those values right there. These are rounded 3 decimal places, but those are the same numbers. So you can get the intersection of the graph too. And let's take a look. Where are we at? All right, next question. The radius of the gears produced at a factory must be 6 inches in length with a tolerance of 0.1 inches. The gears with radius beyond the tolerated lengths will be thrown away. Which of the following inequalities can be used to assess which gears are eligible? Anytime you do an absolute value inequality when you're doing tolerance like that, is you always put your x minus a number is less than or equal to a number. That's going to be the general output for these. So what we're looking for is we're looking what number is going to go in here, and that's always going to be like your ideal number. So the radius should be 6 inches in length. That's going inside the absolute value. How much it could be off by is your tolerance. That's going to go outside. And so it'll be this one right here. Where's that? But to visualize what that looks like on a graph, just so you can understand the relationship between the absolute value and the acceptable numbers, I want you to think of it like this. You can tolerate any numbers between 5.9 and 6.1. That's that 0.1 above or below 6. And when you do it like a shaded inequality, you can see anything between there is acceptable. So like 5.95 or 6.05 would be fine. And question 10, last question on this one, and then we'll do the other 3 in separate videos. All right, this is an absolute value inequality. We want to isolate the absolute value, so we're going to add the 5 onto both sides. That's going to be 21. Then we're going to divide by 3. That's going to give you 7. And let me write that over here. So you have absolute value 2t minus 3 is greater than 7. I like to do a negative 7 greater than 2t minus 3 greater than positive 7. And then we can add 3 to both sides. So it's going to be negative 4 greater than 2t greater than 10. Then we can divide by 2. And so we say negative 2 greater than t greater than 5. So that means t is less than negative 2 because we flip that around. And then we say t is greater than 5. So we say or t is greater than 5. So it's not the one where it's between it, it's where they're separated in different directions. And again, I'll back that up with a graph here. So we say 3 absolute value to x minus 3. Always got to use x in Desmos. Minus 5. And we can say greater than 16. And you can see how it's shaded. Let me make that a little bit bigger. All right, take a look. So this is x, this is the dashed line means it's not including that. So anything to the left of negative 2 is shaded. So x is, or in this case t, x is less than negative 2. And anything to the right of positive 5, not including 5 because it's dash, is shaded. So x is greater than 5. So that backs up our answer choice. Excellent. So I'll do the next 10 problems in a different video. Thank you for watching.